Okay, so this question here, we've got water that is acidified with sulfuric acid and it is decomposed by electrolysis. The water is decomposed to produce hydrogen and oxygen, and a sample of hydrogen is mixed with the air and ignited. State what would happen. So we need to remember that this is the chemical test for hydrogen. So what will happen is the hydrogen will burn with a squeaky pop. Okay, to get the mark, make sure you explain that. Burn with a squeaky pop. Okay, here is the experiment behind this. As it says, throughout the experiment, the volume of hydrogen and oxygen were measured. Now remember, water is H2O. So if we decompose this, break it down, we are going to get for every oxygen, there are two hydrogens. So we're going to use hydrogen and oxygen, but for every time we get one of these, we'll get two of these to make it work. Okay, because that equation to be balanced is going to need a 2 there and then a 2 there. So we can see that in the data. So there's 2 marks, this answer. And what we're going to say here is, first one is that as the time increases, the volume of each gas increases. And the second observation is that the volume of hydrogen is twice the amount of the volume of oxygen. So you can see here, there's 4 centimeters cubed of hydrogen compared to 2, and then 8 compared to 4, and 12 compared to 6, and 16 compared to 8. So 2 marks, there's your 2 points. Okay, next bit, molten lead bromide is electrolyzed. The products are, so remember the definition of electrolysis is breaking down compounds into simpler substances. So here is my lead bromide. So I'm going to get lead from that, and I will get bromine as well. So the only one that matches that is option C. Okay, next question. We're told that these 2 compounds are ionic. That means they contain ions. Calcium nitrate is mixed with water and behaves as an electrolyte. Remember, electrolyte means the ions are loose and free to move, and that's because the only time that happens is when it will dissolve or become molten. So it's mixed with water, it's dissolving. Calcium carbonate does not behave as an electrolyte. Okay, so that means it's not dissolved. Explain in terms of solubility. We've got the answer, haven't we? So we need to say that the calcium nitrate, so the calcium nitrate is soluble. Oh, hang on. The calcium nitrate is soluble, and the ionic lattice breaks, and the ions therefore are free to move, so it will conduct electricity. But calcium carbonate is insoluble, so it means it doesn't dissolve. Therefore, the ions remain in the lattice structure. That means they're not free to move, and it will not conduct electricity. Okay, the final one is a 6 marker. It's quite a biggie. Let's have a quick look at this one. So we're told we've got impure copper can be purified using electrolysis. We've got an anode that is made of impure copper. So looking at my picture here, I can see the anode. I've got my cathode made from pure copper. Here's my cathode. And the electrolyte is copper sulfate. So this is important because this means there are copper ions in the solution. Okay, and what's going to happen here, just remind ourselves, is the impure copper is going to break down and it's going to produce copper ions, and the copper ions are going to head to the pure cathode where they'll make fresh copper at that point. Okay, it then says during electrolysis 3 observations are made. The first observation, the size of the anode and cathode changes, the solid appears directly beneath the anode, and the colour of the copper sulfate does not change. Copper sulfate solution does not change. Okay, so what I've got here, this is a 6 marker. There are 3 stages, 1, 2, 3. So each stage is going to be worth 2 marks. I'm using this to help me to do it. So taking it in the stages approach, stage 1, what's happened to the anode and the cathode? Let's have a quick look. So the cathode, this is where the cations, the copper ions, go. And the copper ions, when they get there, pick up electrons, gain electrons to form copper metal. So because this is gaining, this is an example of reduction. Remember, oil rig, oxidation is loss, reduction is gained. This means that copper metal is formed, and that means the cathode is going to increase in size. So what I would see happening on the surface here is brand new copper would start to form, and this would make this become larger. At the anode, the opposite happens. So if you notice, this equation is the exact opposite of this equation. So my copper metal breaks down to copper ions, and it does that by releasing 2 electrons. So it's losing electrons, so that's oxidation. Copper ions are formed, so they're formed here, and they're going to go into the solution. And the anode, because the copper is forming copper ions, the anode is going to start to get smaller in size, decrease in size, okay? So there's tons and tons there for the 2 marks for that first bit. Second bit, the solid appearing underneath, right? So at the anode contains copper. The copper breaks down to form copper ions. When it does that, all the impurities that are in this material start to drop to the bottom, and they form at the bottom a little pile and collect underneath the electrode. So in words, that's what we've got. We've got the copper electrode forms copper ions. This releases the impurities as our reaction takes place. And the impurities are collected underneath the electrode. Right, the third one is explain the colour of copper sulfate, why it doesn't change. So here we go. So what we've got here is the solution contains copper ions, and that is why it's going to be a blue colour. The copper ions are being removed from the solution at the cathode because they're making brand new copper, but they are released into solution at the anode as the copper breaks down into copper ions. This means the concentration of copper ions remains constant, and therefore the blue colour does not change. It's quite a lot again, but little bullet points, and you would expand on that in your writing. And what's really powerful in this type of question is including little diagrams like this. And the other thing that's really powerful is including the symbol equations, because that really shows you know what you're talking about.